Great. I hope you can see my slides. Yeah, okay. Hopefully we can move this one away. Hopefully you can hear me. I'm chairing the AAIA European AI Summit. I introduced myself before, so just quickly to say, my name is Zhongdong Wang. I'm a professor of electrical power engineering. I'm an IEEE and IET fellow. I'm also the SEGRE UK regular member on the A2 study committee, which is the technical council for large electrical power networks and systems. So I represent UK in the industry organization for the technical council, which is prepare technical brochures to become an IEC standard. My job title at Exeter University also is head of Exeter Energy and director of the Center for Smart Grid. I joined Exeter from July 2020 during pandemic after working for Manchester University for 20 years. So my group in Exeter is still quite young. So what I like to do is probably following what George has set up the energy scene in Europe so beautifully. So what I like to do is probably go quickly through of my view of how AI has been applied in energy sector and what is the future perspective. I think that's what I'm trying to deliver in terms of message. Very quickly to say in the UK, our situation is very similar as what George discussed about. So we're actually an industrialized country, and our system has been built in 1950s, 60s. The national electrical network has been built during that peak time of industrialization or electrification. And then at that time, we have a traditional system, have power generation, transmission, distribution coming to customer. So it's only one direction flow. And we use fossil fuel as the main source of energy in terms of generating electricity. I would say since 2010, the transition of renewable energy generation and also our transmission distribution system, especially with electricity marketing, has been changed significantly. So we have more and more proportion of onshore and offshore wind generation for the UK network. We want to replace the fossil fuel for the environmental protection. And we see the future is very much about renewable dominated electrical energy network and systems. And our future's challenge is really about when can we stop combined cycle gas turbine, which really providing the biggest proportion of the energy we need in the UK. And how can we stop using the natural gas methane and switch into probably green hydrogen? And how can we source energy when wind and solar output is extremely low? Thinking about UK's high demand of energy is actually in winter to heat up our house, and UK is notoriously having no sun. So if there's a winter day, no wind, no sun, what do? We probably need to rely on energy storage and seasonal energy storage. And with all these scenarios of every consumer becomes a consumer as well as producer when they start to install macro solar panels, macro wind farm in their house, do we still need a national transmission network? So I think those are the challenges we're going to see in the future. Just give you a snapshot in 2021 November, a typical day of the UK, how our energy has been generated. You could see actually the cyclic load profile is very clear for that day. And you can see of our CCGT combined cycle gas turbine actually provide majority of the energy we need. This is only for electricity. And then, of course, of that day, winter day, we have a good wind, so we have a wind generate quite significant amount of energy there. Nevertheless, we rely on the interconnection with Europe continental. We rely on other renewables to meet the demand. So our let me try to see whether I can change the okay. Our aim actually is trying to reduce the reliance of fossil fuel and really changing this one into 100% renewable for the future, of course. So George has talked really beautifully about to really make a net zero energy system for the future. We actually need quite a lot of research in renewable generation, energy storage, as well as smart grid. But we also really need to look at of our environmental, societal demand, and also we need to change policy. So there's a policy drive, which is really important for us in terms of net zero energy research. Fundamentally, we just need to stop using fossil fuel, and we really need to go and exploit the real-time solar energy available with wind, PV, wave, biomass, hydro, and we need to stop releasing carbon stored in the underground. But this is actually creating a real difficulty in terms of the green energy sources often is intermittent. So this intermittent source actually affect our electricity network operation. Without massive seasonal energy storage, our system operating is actually minutes by minutes. We need to balance between generation and demand. Otherwise, we would have a problem with maintaining frequency and voltage. That is a fundamental principle for us to operate electrical power networks. So smart grid is really about balancing of electrical energy supply and demand without resorting to the burning of the fossil fuel. Quickly to say like I mentioned, we set up Center for Smart Grid in July 2020. Within 2 years, we actually managed to have 5 academics in position. We're also recruiting another 1 professor. We have currently 10 postdoc and PhD researchers with us in the center, but we're recruiting 6 more. So UK situation is actually we need skilled researchers, engineers to help us fulfill the net zero future in terms of energy. Facility-wise, I think for us to really have a net zero energy systems, we really need to do real-time simulation of the scenarios in the future, how we operate the smart grid, which is basically a cyber-physical system, involve multi-energy sources, involve demand side of participation into the clean energy network operation. So in that sense, we need quite a lot of simulation manpower, and we need a lot of simulation activity. Our electrical network actually is a legacy network. People talk about network have a 50 years of lifetime. That lifetime is actually relying on we maintaining the same demand. Also, we remaining the same sort of redundancy of the network. With electrifying heat and transport network, the demand will be doubled, at least in the UK. And also of the thermal stresses on our legacy system really means that we need to invest billions or trillions into the network infrastructure, which really require of novel, smart insulation materials for our high voltage systems. So I see a lot of research actually discuss about especially the Oxford University's discussion about basically the chemical reaction. I think that's actually a great thing for us because of we also use molecular dynamic simulation to understand of dielectric insulation behaviors. We also do CFD to understand thermal behaviors. My point of single research discipline can solve problem. That era has gone. We really need to work together. AI is a good example to show of mathematicians and computer scientists can work with engineers. But even across different engineer disciplines, we need to work together in order to solve practical problems at the environmental, economic growth, or both. So research facility is actually quite important for us. Our center's research area involve quite a lot about of resilient and future-proof planning of the electrical power networks, enable maximum deployment of renewables, and making sure rapid deployment of low-carbon technology. But most importantly, actually, we are looking into digitalized network infrastructure and also applying data science and digitalization to manage the network operation and the asset. I think there's a 4D actually mentioned quite a lot in power system operation or energy system operation in terms of deliver a secure and resilient operation of the energy systems. We have the demand for decarbonization, and then we would have the naturally of traditional generation, transmission, distribution will be blurred. And then we're really going to stop decentralization. We're going to allow demand participation and everybody become a prosumer. That really require a proper market design, also require AI, IoT technology, which really comes into the digitalization for the electrical network. Our operation would be data-driven, real-time, and computational distributed, and also using AI to help us run the network. Last but not least is really democratization. Really try to move forward to stop of unnecessary regulation, to really making sure society have the ownership of producing and using clean energy and have the public participation. I think that is probably a big picture to show the 4D for the energy transition. I want to say actually there's a lot of AI research in electrical power networks. We're not short of research and development activities. But uptake of this AI technology in the real energy sector in terms of operation is actually quite difficult. The figure here actually shows we could look at effect of offering, which is basically increased opportunity and impact, but we can also look at the serious actions energy sector need to take in order to achieve a specific goal, whatever the goal is, either it's better or more accurate forecast, whether it's taking more renewable energy or whether it's about better pricing, benefit everybody, or even just having a sort of a good maintenance strategy for the infrastructure. If you look at the current situation for energy sector and the future situation for the energy sector, we're actually seeing we could do moderate to a lot actions in order to achieve moderate and a lot impacts. We are actually in a very fortunate area close to moderate, which actually I'm going to talk about the reasons for energy sector, why we look like conservative, why we look at we are not really taking up the advantage AI digitalization technology can give to us in terms of how to run our power network and the energy systems. Before I move into that, I want to say actually our power system is quite smart. We just want to make it smarter. Actually, over the last, I would say, 30, 40 years, we actually use a lot of modeling and computer to help us run our national transmission distribution network. Particularly for the last 20 years, the IoT skills has been actually used quite a lot, and IoT skills are frequently required by the energy sector. So by having IoT devices, we could really optimize our generation, transmission, distribution, and also creating a pricing strategy and help the interaction between energy supply firms and customers. But they're not sufficient for the net zero future. So moving on to a quick summary about the enhancement provided by AI to energy systems. If you look at the research publications produced by various researchers all over the world, American, Europe, and China, Indian, as a large quantity of publication producers, we are not short of research activity on use of AI in electrical energy system or even renewables. You could really see a lot of publications, good publications, looking at AI algorithms, using of IoT, using machine learning algorithm to help us managing the intermittency of renewable energy sources and energy generation. There's a good algorithm come out to really manage supply and demand, and there's a good efficient power system operations, digitalization of infrastructure, have a better maintenance schedule, you name it. There's a lot of good ideas. And we actually know for AI to make breakthrough for us in terms of energy, I think AI used forecast to really help us to reduce uncertainty and offer benchmark to control the power network's real performance, and helps realize of the enhanced production demand in terms of energy, workforce turnover, cash flow, distribution requirement, and personnel forecasting and inventory. There's a lot of opportunities presented for AI to help us streamlining of energy network or energy sector's operation. Also probably want to say for the legacy power network, actually there's a great opportunity for us to develop digital twin for us to manage the infrastructure. Our situation about energy system is very much about giving them greater transparency and also avoiding cyber attack on them, because energy is such an important commodity for the society. I remember somebody said nowadays you cannot think about without electricity, because your mobile phone doesn't work, your Wi-Fi doesn't work, you cannot communicate with people. So electricity becomes such a backbone for the society's operation. The way we want to reduce fossil fuel usage actually really means we need to start involve public into the operation of the electrical network. And that actually means we are going to be having a lot of large volumes of open data, to help us manage supply and demand. For the legacy network, they would be really experience unpredictable load, which creating thermal stress, and we could have a topology change of the network very frequently, which really creating electrical stress in terms of switching over voltage. And the possible extreme weather condition could creating more lightning strikes, elevating ambient temperature, extreme the wind, weather condition. This all creating threat for the secure operation of the electrical network. So the solution AI can help us is actually help us to build a digital twin equipment or power system infrastructure. And that could really help us relying on advanced modeling techniques, measurable condition and health status, and using artificial intelligence and machine learning algorithm to help us derive real-time decision to run our network. And I think this is probably a quite important area on top of the area I mentioned in terms of energy forecasting, of demand supply management. This is a new area for AI to work in energy sector. And I would say of digital twin of power system infrastructure actually becomes quite important for us in the next few years if we want to achieve net zero. This is actually involve quite a lot of work in terms of modeling capability, accumulating large condition monitoring data, and also using artificial machine learning algorithm to learn among different devices, to learn those hidden informations inside of those monitored data. And then we would then provide the tangible benefit in terms of fault location, pro-diagnostic decision, and really avoiding failure of the equipment and network. So there's a tremendous opportunity for this. Okay. After painting that big picture to say, yes, energy sector needs AI technology, and also we have that sort of research there already done to help us. I do want to say something of the reality is actually quite frustrating, because if you look at the United States energy sector in last 10 years, when they recruiting people, either manager or engineer from the higher data in terms of job descriptions, you would see the proportion of the job description requiring the real skill in AI, IoT, big data, robotics. Actually, the number increased, but not increased massively. That is the reality of the energy sector. What's going on? The first thing about energy sector I want to say is about it is capital intensive and long-term oriented. So our energy sector, the building it costs a lot of money, and with renewable coming in, that will cost even more. And electricity, like what I said, is a commodity for the society. The society expects the electricity to be there, switch on 24/7 with no interruption, with high reliability, and its instantaneous supply. That is the current expectation from the customers to the electricity supply. Without the storage, actually the electricity generation demand needs to be balanced minutes by minutes. Therefore, the network needs to maintain voltage and frequency within a narrow operational range with high reliability, and resulting in outside world computer scientists and mathematicians who are really good at AI look at us to think of the electrical energy sector is conservative and clumsy. Okay, and they are not really that active. But you forgot actually of this really high reliability we require and you require as a customer. So I think of small startup entrance firms can really be more dynamic, and because they're driven by maximize their margin and financial return, I think they will be the driving force to apply AI and the emerging digital technology to improve their own operations efficiency, but also provide a niche to the energy sector. With proven technology, I could really see if large company could really become the adapter and driver for the latest AI technology application in the energy sector. So my conclusion is I think there's a lot of good research going on. We need to continue to not only doing research, but also develop this AI application in energy sector. And energy sector is really at the forefront of net zero future, and the transformation going through is actually massive. So AI could become an enabler for us to run this complex data-related energy industry. And I could particularly see of energy demand forecasting, energy generation and conversion, energy price forecast, integration of more renewable energy sources, and energy storage could be really well suited for the characteristic of AI technology, and the application in the energy sector could be really successful. And energy sector actually welcome AI big data implementation in the sector. They are already using IoT and massively improve the performance. Robotic has been really used now in substation. So I could see if this emerging technology could be exploited by the energy sector. But most of all, I really agree with George. We really need to educate the policymaker, the regulator, as well as the medium, to really educate them to say policy and regulation need to be in place to encourage AI application in the energy sector in order to move the sector forward. And we also need to develop AI technology which can be better than human decision-making process. They need to have high reliability for all scenarios of the network operation or electrical systems. So without those high reliability, without the opportunity to be better than human decision-making process, we would not be able to take advantage of AI in the energy sector. With that sentence, I finish my presentation. Thank you very much. Okay, so I'm going to stop sharing. And I'm still pleased that we have 205 people here. So that is our last presentation. I'm going to put my email into the chat, and hopefully if people are interested in what I talked, and we could have individual communications. Okay, we're heavily delayed in running due to various reasons, but I think mainly to blame is my chairwoman skill, in terms of I didn't stop a lot of people talking over the time, probably including myself as well, I don't know. Anyway, so I'm delighted to have this AAIA European AI Summit. I think this is the first time we have it. And the keynote speakers are really all excellent. And you spend your time here with us. And we have a massive audience. I want to thank the team in China, who actually stay after the midnight to support us in terms of providing all the services at the back of these presentations. Everything ran quite well. So thank you very much for the speakers, and thank you very much for the audience. And I look forward to next European AI Summit in the near future. So without further ado, I want to bid you a very good evening and good night, and have a wonderful evening and enjoy your summer or autumn. Okay, so goodbye, everybody. Thank you.
Goodbye. Thank you.
Thank you.
Goodbye.
Bye. Bye.
Bye.
Thank you, everybody. Thank you. Thank you, Jessica and Jack. Thank you very much, everybody. So see you very soon then. Bye.